All right, friends. Oh, yeah, she is.
She was crying the other day.
Yeah. Okay, so back to doing this again. You have an electronegativity table. It looks like this. As we move across the electronegativity table, going this way, what happens to our electronegativities?
Decrease.
They increase. So on your table, it's very hard to see on this thing. Maybe I can turn the light on. That kind of helps. Okay. These little numbers, which it will be color online, so that'll help, are your electronegativities. And as you move across the table, they're increasing. Fluorine, look at F, everyone. What is special about F? It's got a 4.0. Does anybody else have a 4.0? No. Fluorine is the highest electronegative element. It has the most electronegativity. Now, if we think back, electronegativity means how bad an element wants electrons. So do you think fluorine gives electrons or takes electrons? If electronegativity means how bad an element wants it, and fluorine has the highest, so it has the highest want of electrons. It takes. It steals like crazy. It does not share at all. If you look over here at hydrogen, which is only a lowly 2.1, this is a little baby, and underneath it we got lithium, that's 1.0, 0.9 for sodium, 0.8, all these little dinky numbers. Do you think that these elements are giving electrons or taking electrons? Giving. So a note that we could add to our table if we wanted is that higher, I'm just going to write En for electronegativity, equals take electrons. And remember, that's my electron symbol. E with a negative. So a higher electronegativity takes the electrons. And in case you haven't put 2 and 2 together yet, we're going to start putting things together and figuring out if they're going to take or give electrons.
Seems good there. It's funny.
I am funny, actually. I'm hilarious. I'm hilarious. I have a 3-year-old that laughs at me all day. All day long. Now, let's look at your table again. You'll notice that these elements do not have electronegativities. Why? What are these elements? Noble gases. And what was special about the noble gases? They are noble. What do they not do? React. Very good. They don't react at all. In order for something to react, it has to be able to bond. It has to get to an octet. Whether it's taking electrons or giving them, it has to do something to get there. The noble gases already have 8. So they're happy. Their electronegativity is null and void. We don't even care about it. Because they're never going to bond. Ever. Anyone ever tells you a helium balloon is explosive is lying to you. I don't know why that's a common myth. But a lot of people think helium will catch on fire. It won't. It can't. Hydrogen will blow up really fast. Helium will not catch on fire. It can't. In order for elements to do anything, they have to have outside electrons with an electronegativity. These bad boys, we just leave them off because they're stupid. Same, if you notice, with this bottom row right here. These UUU ones. Oops. Well, on this one, UUUs. On my periodic table board, they have names like CN instead of UU whatever. Doesn't matter. Those just mean that they were discovered recently in the last 10 years. Sometimes they give them a name, sometimes they don't. My periodic table on the wall is old enough to where it doesn't have them named yet. Your periodic table doesn't have them named yet. Doesn't matter. But all of them that are left off don't have an electronegativity. They're not going to react. We don't care about them. The difference is these bad boys right here are not reactive, not because they have 8 electrons. Anybody got a guess? What's something we just watched a movie on? Radioactivity. So these guys down here are so nuclear, so radioactive, that they immediately start breaking themselves down and they don't bond. There's no point in even knowing whether they bond unless you're going to go into nuclear medicine. And guess what? We're not, so we don't care about them. Okay? So any questions about how to read this table? The little numbers are your electronegativities. If you want to write that, you can. If you think you'll forget. As we move across, they increase. And the higher electronegatives are going to take electrons. And I'm going to go ahead and add, you don't have to if you don't want to, that the opposite, lower electronegativities, give electrons. Okay? These are all notes that might help you later in life to have on your periodic table. They might never help you. You might be really, really good at this and never need to look again.
I'm gonna be good at it.
I bet you will. Okay. I gotta open my internet again. So there is a rule, and I want to check it before I write it down because I think it's 1.7, but I don't want to say it wrong. You ever do that where you think you know something and you're like, I gotta check it?
Yeah.
I do all the time. I might pull it up and show it to you anyway. Okay.
I actually shoot. Do you see
Yes.
you know what it says, right?
I'm recording. Can you talk to me in a second? Well, you're gonna have to wait. Okay, one more note that we're gonna add that might not make sense yet, but it will. There's a spectrum that I'm gonna put on the board, and it's gonna be on the board forever, but it's good also to have on your periodic table. That bond, I'm gonna actually make this arrow right here. I'm gonna make a whole spectrum. Okay? And on my spectrum, I'm going to put 1.7 somewhere near the top. Not all the way at the top, but somewhere near the top. And I'm going to put 0.5 somewhere near the middle. And I'm going to put, actually I'm not going to put anything under 0.5. Okay? So like that. All right, I'm going to make my arrow a little bigger since I have people watching it from home so that I can show. So notice this is a continuing line. Okay, you learned about continuing lines in math class. Lines go forever unless they have a segment at the end, unless they have a dot at the end. This line goes forever because it's about numbers. It's like a number line. There are infinite amount of numbers. So don't think that 0.5 is a stopping point or 1.7 is a stopping point. Okay? Anything 1.7 and above is called ionic. I-O-N-I-C. That was a really weird looking in, but it's an N. So anything above 1.7 is ionic. Okay? Anything that falls in this middle area from 0.5 to 1.7 is called polar, like a bear. I actually have a really funny cartoon about polar bears and polar bonds that will just make you roll on the floor laughing in a little bit when you understand what it means. It's not, it's like a newspaper cartoon. No one's ever laughed at it, but I think it's hilarious. And then anything under 1.5 is non-polar. So it's not a polar bear. I know that it might not make sense yet. But all of these are things we need to know in order to do practice problems and understand why we're using electronegativity. So what this spectrum tells you, when you put two things together, so let's say I put fluorine, which, let me move back to the screen. Fluorine has an electronegativity of 4.0. And I bonded fluorine with lithium. Okay? What electronegativity does lithium have? 1. What's 4 minus 1? 3. Where does 3 fall on this spectrum? Ionic. Way ionic. Okay, that's all the spectrum's telling you. You don't know what ionic is. You don't know what polar or nonpolar is yet. You will. But for now, just know that when we bond stuff, we're going to be subtracting their electronegativities and finding where it falls on this scale. Okay? We ready? Let's do some practice. We are also going to practice drawing Lewis structures because that's always fun to practice. yeah. So I'm going to stop this video and post another video showing practice problems so that the videos aren't 45-minute long. If you have questions, email me.